purpose of this recording is for you to be able to calculate percent error. And percent error is a percent that describes how close an experimental value is to a standard. It's like getting feedback about your experimental data. Now, this is a non-science example to give you an idea of what percent error is. Dr. Square told somebody to smile. 3 people smiled, and here is the accepted standard, the smile. Here's what somebody did, and here's the feedback that they got. This feedback, the thumbs down from Dr. Square, is like the percent error. As you can see, these two also got some feedback on how they did. Now, percent error had a voice. This is what it would say. They want to be close to 1, or excuse me, to 0, because 0 means that your experimental and your accepted value are very close, and that means accuracy. That means your experimental data is accurate. While a large percent error means your experimental value is inaccurate. Now, in terms of the negative and positive, if it's negative, your percent error, if your percent error is negative, what that means is your value experimental is greater than the accepted value. And if it's positive, your experimental value is less than the accepted value. Now, here is percent error's formula, and this is how you would calculate it. Your value accepted minus your value experimental, and that you minus the 2 of those, and then you divide that difference by the value accepted, and then you multiply multiply your answer by 100. Here are the steps, like just what I said. You'd minus these 2 values, divide that by this, and then multiply by 100. Let's say a person gets water's density at 0.98 grams per milliliter, and the standard value is 1.00 grams per milliliter. What is the percent error, and what does this value mean? So, when we do these kinds of problems, we're going to set it up with the 4-step format: info, formula, substitution, and solve. The info in this scenario is that I know that my value accepted is 1.00 grams per milliliter. My value experimental is the one that they got, the 0.98 grams per milliliter, and I want to know the percent error, so I make that x. Now, the formula that I'm going to use is percent error equals value accepted minus value experimental times 100 divided by the value accepted. Now that line should be there because it should be division. So the substitution step would look like this: 1.00 grams per milliliter minus 0.9 grams per milliliter, that's in parentheses, divided by 1.00 grams per milliliter times 100. Now the first thing I'm going to do is I'm going to subtract, and I'm going to subtract this number from that number, and I'm going to get this: 0.02 grams per milliliter divided by 1.00 grams per milliliter times 100. The next thing I'm going to do is divide. Now, these units are identical, so these units will cancel. And I'm going to be left with just the quotient. And the quotient is 0.02, and I'm going to the next thing is to multiply that by 100. So I'd multiply, and I get x is equal to 2%. So that is my answer. So, in terms of what this means, it means that I've got a value of 2% error. That's very accurate data, good data, and there's not a lot of error within it. And that's something that makes Dr. Square very happy. Oh, you're kidding. I thought I had not recorded the whole thing.